Today we are going to discuss a destructor. Destructor means what exactly destructor is, when to use destructor function, how the destructor function is implemented, right? Behind the scene, what exactly happening, how the destructor method is called by the garbage collector, with what is the best way to destroy unmanaged object in your application, what is the best way to destroy the heavy resources on your application. Everything we are going to discuss as part of this session, right? So first of all, what is destructor? According to MSDN, destructor, which are also called as finalizer, are used to perform any kind of a final cleanup when a class instance is being collected by the garbage collector. Okay, let's go to the MSDN site and check the definition. So this is the MSDN site, and you can see finalize historically referred to as a destructor, right? People who are using other programming languages like C++, like Java, they are referred to this concept as a destructor, but in C#, we are calling this as finalizers, right? So finalizer and destructor meaning are going to be same. And what is they are used for? They are used to perform any kind of a necessary final cleanup when a instance is being collected by the garbage collector. That means when one of the object is not used, then that object will be eligible for garbage collection. Then the garbage collector will come and destroy that object, so that what memory allocation will be done for that object is freedom, right? So that memory allocation is freedom. So that is the purpose of destructor, right? Now, if you simplify the above definition, then what you can say, now destructor is a special type of method that is also present inside a class like a constructor, right? Like a constructor means what? Now it is also having the same name as the class name, right? So what is the name of your class? That is the same name of your constructor, even though the destructor name is going to be same. To differentiate between constructor and a destructor, the destructor function is preceded with a tilde symbol, right? So you can see this example, right? This is your class called example. In this class, I have one constructor and one destructor. You can see the constructor without tilde symbol. To differentiate, this is a constructor and this is a destructor. We are preceded the destructor function with the tilde symbol. Once you preceded this with a tilde symbol, then it will become a destructor. And as part of the destructor, whatever cleanup statement you can write, right? Cleanup statement basically the memory releasing statement. That is basically you can also say that object destroyed statement. Whatever you want, you can write inside of this destructor, right? The point that you need to keep in mind is that a destructor method cannot have any parameters. Like, say, you can see you cannot pass any parameter. In a constructor, it might be your zero argument parameter or it might be n number of parameter you can pass. Constructor can be overloaded, right? But destructor cannot be overloaded because you cannot pass any parameter. Only one destructor you can define inside a class. Again, the second thing that you need to remember is the constructor you can create with any access specifier like public, private, or protected. You can also use modifier like static, right? But you cannot use such modifiers with example. That means you cannot create a public example or private example or a static destructor. You cannot create a destructor using public, private, protected. Even you cannot use static, right? And another important point that you need to mind is destructor functions are called implicitly, right? Destructor functions are called implicitly by the garbage collector. So when the constructor is called, now whenever we create an instance, if it is a static constructor, then it is implicitly called when the class execution starts, right? For the first time. But if it is a non-static constructor, then when we create an instance of that class, then that non-static constructor is going to be invoked. That is explicitly we are invoking the non-static constructor. But destructor, you cannot invoke it explicitly. Destructor are invoked or executed implicitly, right? So then it is you can compare this destructor function is very much similar to your static constructor, right? Static constructor without parameter, static constructor without access specifier, destructor without parameter, destructor without access specifier. Static constructor are all implicitly called. When they are called implicitly, now whenever your class execution start for the first time, then this destructor is called implicitly. When this destructor is going to be called implicitly, when the object is destroyed, right? When the object is destroyed, now when the object is no longer used, now, then when the object is no longer used, then what will happen? The garbage collector will come and the garbage collector will call this method, right? As a developer, we are not calling this destructor method explicitly, right? As a, then what is who is take the responsibility to call this method? It is the responsibility of garbage collector. The garbage collector will check, yes, this object is no more used, this object is unused. Let's call the destructor of that class. Because whenever we are creating an object means it is related to a class, na? Then for the class, for which class you are creating the object, it will call that class destructor to destroy that object, right? Right. So when a destructor method is called, a destructor method called automatically by the garbage collector when the object of the class is destroyed. So the point that you need to remember is the destructor methods are automatically called by the garbage collector. We as a developer, we can never call the garbage collector. We can never call the destructor. At most, what we can do is we can request garbage collector, hey garbage collector, can you execute the destroy method? That what we can do at most, but we cannot call this destructor. That I will prove it. I'll prove all these things in detail. So as of now, did you guys understand what is exactly a destructor? What is the signature of a destructor? Who called this destructor and when this destructor is being called?
Yes.
Yes,
Okay.
sir.
Okay, fine. So now,
Okay.
yeah. So now
It's
we need
okay.
to, sorry?
No, it's okay. It's okay. Thanks.
Yeah. So now one more question that we need to understand when the object of a class get destroyed, right? We are saying that when the object is destroyed means we need to know at what scenario the object is going to be destroyed, right? At what scenario the object is no longer used, right? So the point that you need to understand is suppose you create one program and as part of that program you have written some object creation statement. Then when the program execution ends, then the object what you created for your program is going to be destroyed by the garbage collector. This is one of the scenario and this is common. Suppose you are creating one application inside the main method, you are creating some object, right? When the main method program execution starts, the object are created and when the main method execution end, the object are destroyed, right? And at that time, the garbage collector will come and will destroy the object. And the second point that you can remember is the implicit calling of a garbage collector also occurs sometime in the middle of the program execution, right? Say in the first statement, when your program execution end, garbage collector will destroy the object. That is one point. Second, the implicitly in the middle of the program execution, the object are also destroyed. How they are object? How? Now see, whenever you are executing your application, if there is a shortage of memory, right? Whenever you are creating an object, that object memory allocation will be done inside the heap memory only, right? Suppose you are creating lots of objects, but at some point of time, the garbage collector will see that yes, there is some few memory available inside the RAM. So let me do a cleanup. So in the middle of the program execution also, garbage collector will destroy the unused object. This is the second scenario. The third scenario is that we can make a request to the garbage collector explicitly in the middle of the program execution, right? When our program execution is going on, if we want, we can make a request to the garbage collector, hey, Mr. Garbage Collector, will you clean up the unused object, right? Then the garbage collector will decide whether he wants to clean up the unused object or not, but we cannot give guarantee. That is we make the request and the garbage collector will destroy the object. That is not sure, right? We are requesting to the garbage collector, then it is the responsibility of the garbage collector to destroy the unused object immediately or not, right? But most of the time you will see that once you request the garbage collector, he takes responsibility, he gives respect to our request, right? Once you request, he destroy the unused object. So in these three ways, one is at the end of the program execution, one is middle of the program execution implicitly by the garbage collector, third one is explicitly in the middle of the program execution. So in these three way, the object are destroyed, right? Now let us see some example to understand these things, right? Suppose I'm creating one example, right? So in this case, you can see uh, I'm creating one class called a Destructor demo. Let me increase the font size. Yeah. Now it's visible to all of you clearly.
Yes.
Okay. So this is one class, right? This is your constructor demo class. And in this class, I have created one constructor and I have created one destructor, right? You can see the constructor name and the destructor name both are going to be same. That is the class name. To differentiate that it is a constructor and it is a destructor, we have preceded this destructor with this tilde symbol. Further, you have a public, private, protected access specifier with the constructor function, but you cannot write anything you cannot write. If you try to write, you will get some compile time error. Suppose I am writing here public, right? You will say one const error, right? What is saying the modifier public is not valid for this item. For this item means it's a destructor. For the destructor, no access specifier you can apply, right? Again, if you are trying to pass some parameter, then you will get some error, right? So you are getting some error. What error? Destructor must declare a body because it is not marked at a, okay, right? So you can see here it is saying giving mark field as that means if providing the integer x, then we are getting some kind of error. That means the destructor function cannot take any parameter. Then what we are doing as part of this destructor function? Now we are just getting the type of the class. So whenever you are writing get type dot name, it means it will give you the name of the class, and we are writing this that also, and this statement will give this destructor demo object. Destructor demo is destructor. So when this destructor function is called, then this statement is going to be executed. It will execute object, and this type is replaced with this type. So what this type is going to contain? It contain the get type dot name. So what this get type is going to provide? Get type means destructor example dot destructor demo, but we are only interested in the name. So it will provide you the name. Name in the sense, what is the name of your type? The name of your type is destructor demo. So it the statement will be like this will be replaced like this. Destructor demo object destructor demo is destructor, right? Then what I am doing inside the main method, I'm creating two instances. Instance 1 and instance 2. This is your object 1 or instance 1. This is your object 2 or instance 2. This instance is referred by this object 1 reference variable, and this object 2 reference variable referring to the second instance, right? Making object 1 for garbage collection, right? So whenever a object is unused, then that object is eligible for garbage collection. In this case, you can see this is your first object, and this object is referred by this object 1, right? If you are making object 1 equals to null, then can you use this object anymore, guys? No, you
No.
cannot make the, see, once this object reference is stored inside this variable, so using this object reference variable, you can access all the members what are defined inside this object, what are they are stored inside this object. Again, if you make this object reference as null, that means there is no more pointer pointing to this object, right? No more pointer pointing to this memory location which is created inside the heap memory. That means now this object is eligible for garbage collection, right? So, and you can see we are making this object to 1 equals to null, means this object is ready for garbage collection. Then at some point of time, the garbage collector will come and will call the destructor function and will destroy the object, or object in the sense destroy that memory location which is allocated for this object, right? Now if you run the application, you will see that the output. Yeah, you can see we have created two objects. So this constructor executed 2 times. Then you might be thinking, sir, we are making the object as null, then why the destructor function is not called? As I told you, who is responsible for calling this destructor function?
The garbage collector?
Garbage collector, right? But we cannot predict, we cannot give guarantee when the garbage collector is going to call the destructor function. Internally, the garbage collector calling this function, so we cannot see the output, right? This is the reason why you can see this function is not, the statement what is written inside the destructor is not printed here, right? Now, if you want, then what at most you can do, you can make a request to the garbage collector. Hey, Mr. Garbage Collector, please destroy the unused object. So in this case, so gc.collect, right? So if you want to make a request to the garbage collector, then you can make a request by using this statement, making a request to garbage collector to destroy the unused object, right? So in this case, we are making obj1 null, means one object we are making null, and then we are making a request to the garbage collector. Hey, Mr. Garbage Collector, can you please destroy the unused object by executing the destructor of the object, right? So this is a class, and in this class we have one destructor, and this object is no more used. So can you execute that destructor function of this class? Then the garbage collector will think about it. Yes, I need to execute the destructor or not. I need to execute the destructor immediately or after some time. That decision is going to be taken care by the garbage collector. Right? Now let's run the application. Right? You can see object destructor demo is tested. Now, once we make a request to the garbage collector, then the garbage collector calling this destructor demo function. We are not calling this destructor demo function. Who is calling? The garbage collector is calling this destructor demo. And this destructor function is executed only once. Why it is executed only once? Because one object is eligible for garbage collection. If two object is eligible for garbage collection, then 2 times the destructor is going to invoke this function. Let's make both the object eligible for garbage collection. So what I'm doing, I'm making this one null. I'm also making object 2 as null. Right? Now we are making both object 1 and object 2. Both object are null. Null means now both the object are eligible for garbage collection. Right? Both are unused. Unused means at some point of time, the garbage collector will come and the garbage collector will call the destructor function of this class, and that destructor function is going to destroy the unused object, right? Now, let's run the application and see. See, 2 times the destructor is invoked or not? Is that clear?
Sir, does explicitly calling a garbage collector, does that like also increase performance or like memory usage, or will be
yes. That will discuss in our next session. If you are explicitly defining destructor in your application, it will degrade your performance, right? That is absolutely fine. In our next session, we are going to discuss garbage collection in detail, and in that, in our next time, in tomorrow, I'm going to discuss how a destructor in your application degrade the application performance. You should not use the destructor function like this. If you are using like this, then it is going to degrade your application performance. That we will discuss in our next session. Is that fine?
Yes, thank you.
Yeah, we will discuss that. Once we started discussing the garbage collection, which is going to be discussed tomorrow, I will show writing destructor, how it can degrade your application performance. But for now, the point that you need to remember, whenever you are creating one destructor, then that destructor you cannot call explicit. In this case, you can see this is explicitly called to your constructor, right? I mean, it's a function and you are just calling that function. But this is, you are not calling anywhere from your application. At most, what you can do, yeah.
So, sir, like my question is that we can call the destructor by ourselves, but we should not call it.
No, we cannot call by ourselves. There is no mechanism to call the destructor explicitly. Right? So this statement, what you are seeing here, gc.collect, this statement is not calling the destructor function. I will also prove that point that this is not your destructor calling statement. What exactly this statement is, we are just making a request to the garbage collector. Hey, Mr. Garbage Collector, will you check this to, will you check the unused object of our application? If there is any unused object, then please call the destructor function of that class and destroy the object. So we can never call the destructor function explicitly.
Is there a particular order that it goes through, or is it just like random? That it the garbage collector?
Order.
Is it like when it goes to collect the garbage, destroy the object, is like a particular order that it goes in, or just randomly collects them and destroys the objects?
See, order we cannot give any prediction. We cannot give any guarantee that any particular order garbage collection is going to execute, because see, here we are making an explicitly request to the garbage collector. It might be possible that some other applications are running, some other objects are running, which are also ready for garbage collector, right? So in that case, garbage collector will take the responsibility to call this unused object. Yes, some particular point of time you will see that it's a small application. It's a small application means it will call it as we are making a object one null and we are making object two null. Then it might be possible that it will call this object one garbage collector destructor first. Then it will call the object two destructor first. It might be possible like this, but we cannot give any guarantee, because it is not like that the destructor is going to destroy these two objects only, right? In your application, whenever you are running, you might be creating 1,000 number of objects, right? Among the 1,000 number of objects, few objects are going to be destroyed, right? Few objects are going to be unused, right? Once we have discussed tomorrow session, right? Tomorrow we are going to discuss garbage collection. In garbage collection, we have three different generations: generation 0, generation 1, generation 2, right? Then once we discuss the garbage collection in detail, then you will get a picture idea. You will get a better idea how exactly the garbage collection mechanism work, how it destroys the unused object, how it moves the object from garbage. I mean, from generation 0 to generation 1, from generation 1 to generation 2, right? How frequently it is visited to the generation 0, how frequently it is visited to the generation 1, right? Once we have discussed that garbage collection architecture in detail, then you will get a better idea. But you cannot give any predict, you cannot give any order in which this garbage collector is going to destroy the object, because it is not in our control now. It is completely managed by garbage collector. Garbage collector will decide which object I need to destroy first, which object I need to destroy second. That is totally depend on him. We cannot predict or we cannot give any guarantee. Is that clear?
Yes,
Yeah.
sir.
So, and why, I mean, what kind of, what's the practical use of a destructor then? If the garbage collector manage everything and then does it the way he likes, what would be a practical use?
Yeah, at the end of the session, I will give one real-time scenario, right, where you can use destructor and where you can use explicitly how and when you need to use the destructor function explicitly and how you can use destructor function to destroy the object. That one practical example I'm also going to give as part of this session. Don't worry, wait for some time. Is that fine?
Sir, I have one more
Okay.
question.
Yes, ask me.
So in line 10 to 14, we defined a destructor by the name of destructor demo.
Yes.
Okay. So suppose we delete this code, line 10 to 14, and then we make a request to GC in line 27, then also it will work.
Right? Yes, it will going to work, because destroying the object, see, that's what I'm saying now. So once you understand garbage collection, then you will get your clarity, right? The garbage collection
Okay.
will destroy the unused object automatically. But before destroying the object, it will check. It will ask the class, hey, Mr. Class, do you have any constructor? Yes, constructor. Then the garbage collector will not destroy the object immediately. It will wait. It will make a call to the destructor function. Then the destructor function is going to unused. This is the reason why I'm saying that using destructor in your application is bad for performance, because in this case, garbage collector will delete the object immediately. But once you have this destructor function, then before deleting, it will make a request to the call. Hey, Mr. Class, destructor demo, do you have any constructor? Yes, constructor is there. Don't delete the object immediately. Wait for the constructor to execute, right? You understand my point?
Okay. Yes,
Yeah.
sir. Yes.
If your class doesn't have any destructor, no matter, it is used immediately, you will get better performance. If your class having some destructor, means it will not destroy the object immediately. It will wait for the destructor function to be executed. Is that clear?
Yes, sir.
Okay. Okay, fine. Right. See, can you see one more question? So I'm saying that destructor function is implicitly called by the garbage collector. Can you prove destructor method is implicitly called by the garbage collector? Yes, I can prove. Let's see how. Okay. So in this case, you can see I have one class, destructor demo, the same class. Here I'm having one constructor, and here I'm having one destructor. So what I'm doing here inside the main method, I have written one print statement showing that the main method execution started. Then I'm creating one instance of the destructor demo class. One object is created. Then here what I'm doing, I'm making object one ready for garbage collection, right? I'm making object one ready for garbage collection. How I can make it? By setting the object one value to null. Then I'm calling the gc.collect method. Then I'm executing some statement inside the main method. Then again I'm making object one equals to null and making gc.collect method again. So here already we have made null. Again I'm doing the same thing. I'm making object one null and calling the gc.collect method, and I'm printing some more statement executed inside the main method. Again I'm calling the gc.collect method, right? Again I'm executing this statement, that is main method execution end. Can anybody tell me what will be the output of this application now? Can anybody predict what will be the output? Any idea from anyone?
It would be once for the destructor, and that's it, because once that is null, I mean, you cannot destroy it again, right? Well, I guess.
Yes. Any other answer from anyone else?
See, it will be main method execution started, and then it'll be
this is the demo. This is the first statement. Then the second statement.
First.
When you execute this destructor demo statement, right? The object will be created. Object will be created means the constructor is going to be executed. This should be printed as the second statement, right?
Right.
Then what will be the third statement in your application? That is fine. There is no issue that main method execute. Yeah. Tell me which one is the third statement to be executed as part of this
object. Destroy. It's gonna destroy the object. Yeah, that one is gonna be the third statement.
Third statement. Then which one is the fourth one? As per your expectation,
that one.
This will be the fourth one, right?
Yes.
And which one will be the fifth one?
It's gonna be destroyed again. The number two. It's gonna number three is gonna be ran again. Yeah, that one.
Sorry, is it going to execute once more?
Yes.
Okay, so this will be the fifth statement. Then this is going to be your sixth statement, right?
Yes. Sixth statement. Yes.
Again, gc.collect means you are expecting this should be your seventh statement, right?
And again, yeah.
And finally, this will be your eighth statement. This is what your expectation, right?
Yes.
Yes. But I already told you that. Who is going to invoke this method?
GC.
GC. As GC is going to invoke this method, can you predict that this method is once you call the garbage collector, he is going to execute this statement immediately?
It should. If it's null, it should immediately execute.
And one more thing. Once the object is destroyed, so see, this is object one null. That means the object is null. Once the garbage collector execute, that object is destroyed. If that memory is already destroyed, if you are making another request, do you think that he is going to destroy the same memory once more? Already object is destroyed, na? Then how he can destroy the memory location once again? You understand my point? We are having only one object. So we are making the gc.collect method. First time that object is destroyed, constructor executed, that memory location is destroyed. Once that memory location is destroyed, do you think that garbage collector is that term, he is going to again destroy that memory location? No,
it won't find anything.
Right. So once the memory location is destroyed by the garbage collector, right, he is never going to destroy the same memory location once again, because there is no memory. What is going to destroy, na? And we cannot give any guarantee when the garbage collector is going to be executed, right? So in this case, Our program execution will start from here, right?
Hello.
Yeah. Ask
Sir,
me.
in line number 25, the object will be destroyed. This object one
No.
will be
In
destroyed.
line number 25, the object is not destroyed. In line number 25, we are just making a request to the garbage collector. Hey, Mr. Garbage Collector, can you please destroy the unused object? We are just making an object. We are not
Yes, sir.
saying anything that please destroy obj1, please destroy obj2. We are just making the request to the garbage collector. Hey, Mr. Garbage Collector, can you destroy the unused object for our application?
Yes, sir. Suppose like in line number 25, we make a request and it is like it will be accepted. So in again in line number 28, if the object is destroyed, then how can we again initialize it with the null?
See, this is one reference variable, right? You can store
Yes,
this
sir.
reference variable with this object. Even if you want, you can store this reference variable with another object. Suppose I'm saying, if I'm declaring one integer variable with some value, right?
Yes,
If I'm making this value as 0, again, if I'm making this value as 0, is there any problem?
no, sir.
So this is just a value, right? This is just a value, and that value we are storing in this variable. Na? If you initialize this value with this object or null, does it matter? No matter. You can initialize
No, sir.
even if you want, you can reinitialize this object here like this. No issue. This is also
Okay, sir.
acceptable.
Yeah,
This
yeah,
is
got
just
it.
a variable, right? So
Yeah.
what will happen in this application? Now this program execution will start. We are making this object null means it is eligible for garbage collector. We are making the garbage collector. Hey, Mr. Garbage Collector, can you please destroy the unused object for our application? Here we are assigning this variable with null value. There is no link between this variable and garbage collector. Again, we are making a request to the garbage collector. Hey, Mr. Garbage Collector, can you destroy the unused object? Because see, once we make this request and once we make this request, in between these two, we are executing some statement also. It might be possible that some other object might be ready for garbage collector. Yes or no? Right? Again, we are making the request. Again, we are making the request. Even though we are making the garbage collector even though we are making request to the garbage collector 3 times to destroy the object, then at the end, you will see that this function is going to be executed only once because we have only created one object, right? And that object is eligible means that garbage collector is going to destroy that memory location once, right? It doesn't matter how many times you request, whether you request for 0 time or n number time. One object you created, at the end, garbage collector is going to destroy that memory location only once, right? And as garbage collector is beyond of our limitation, beyond of our control, we cannot predict when the garbage collector is going to destroy the object, right? So in this case, it might be possible that after executing this statement, garbage collector might call the destructor function and you will see this output. It might be possible that after executing all this function, then garbage collector will decide and will execute this destructor function, right? So let's see the output. But one thing is sure, the destructor is going to be executed only once. It might be in between or it might be at the end. So here you can see this destructor object is destroyed at the end, right? And how many times this destructor is executed? Only once. So we cannot give any guarantee when the destructor function is going to be executed, and this destructor function is executed only once for one object. Is that clear? Any question?
Yes.
Any question from this example?
So, sir, it is called like in the last step.
Yeah, so we cannot predict now when the garbage collector is going to call the destructor demo object, because that is going to be called by the destructor. Or see, this destructor is going to be called by garbage collector. Garbage collector is beyond of our scope. We cannot control garbage collector. When the garbage collector is going to call the destructor, we cannot give any guarantee. We cannot predict. At most, what we can do is we can make a request to the garbage collector. So here you are writing gc.collect means you are just making a request to the garbage collector, right? then it is the responsibility of garbage collector whether he will going to execute the method immediately, destructor immediately or not. But if you are making 3 times, 4 times request, if you are only if your application having only one object and that object is eligible for garbage collector, it means that object is going to be destroyed only once. It doesn't matter how many times you request, but it is going to be destroyed only once. Is that clear? Yes?
Yes, sir.
Okay. Right. So few points to remember while working with the destructor or finalizer in CSharp. So you can see in MSDN documentation, they have provided few points. Finalizer cannot be in structs. They are only used with classes. A class can have only one file. Finalizer. See, whenever I'm saying finalizer, you have to remember it is a destructor, right? Because historically referred to as a destructor. Now we are saying them as finalizer, right? Finalizer cannot be inherited or overloaded. Give me 1 minute. Right? So finalizer cannot be called explicitly. They are invoked automatically. A finalizer doesn't take modifiers or have parameters. Now let us prove this. So the first point is destructor or finalizer cannot be defined in struct. In CSharp, they are only used with classes, right? You can see this is a class and this is a struct. Inside struct, you can declare finalizer or destructor. But inside struct, you cannot declare destructor or finalizer. The first point, what is mentioning, finalizer cannot be defined in struct. They are only used with classes. This is the first point, right? The second point is, you can see a class can have only one finalizer. Finalizer cannot be inherited or overloaded. If you are only having a single destructor, right? That means if your class having only one destructor, that means overloading is not possible, na? So you can see in a class, you can define only one destructor. That means destructor cannot be overloaded, right? Here you can see this is the destructor, which is without parameter, without return type, without any access specifier or modifier. And when I'm trying to pass some integer parameter, when I'm trying to overload this destructor, I'm getting some error, right? This is the point number 2 and 3. Destructor cannot be called explicitly, right? They are invoked automatically by the garbage collector. At most, what we can do is we can request the garbage collector to execute the destructor by calling the gc.collect method. That is what we have already discussed. So this is sample. This is a constructor calling. Explicitly, we are calling the constructor. We are making the object as null. Then here we are making gc.collect method. gc.collect method means here we are not invoking the destructor. What we are doing here is we are making a request to the garbage collector to execute the destructor and destroy the unused object, right? So this is what we can do at most, right? A destructor doesn't take any modifier or doesn't have any parameters, right? You can see if I'm trying to use the public access specifier, even if I'm trying to use the static modifier, even if I'm trying to pass some parameter to this function, then I will get some error. That means it should be without parameter, without any access specifier. These are the 4 points, 5 points. That is what defined here, right? Is that clear? Guys?
Yes, sir.
Yes. Okay. Yes.
Now we need to understand how the destructor is implemented internally, right? Here we are just creating the class name and we are preceding the tilde symbol. Then we are saying that it's a destructor or it's a finalizer for our class. But behind the scene, we need to check, we need to understand how the code is implemented, right? For that, what we can do is we can take the help of ILDSM, right? We guys know what is ILDSM tool, right? ILDSM means intermediate language disassembler. If you want to check the intermediate language code of your application, right, then you need to use that code, right? So you can see this is a simple class called sample, and in this class I'm having one destructor, right? Now I will look into this code and I will try to figure out how this destructor function is implemented, right? For that, first of all, I need to build the application, build successful. Then I need to open the Visual Studio command prompt. Whatever version you install on your machine, you will find this tool, developer command prompt, right? So I'm opening this developer command prompt. What I'm doing, I'm typing ILDASM, intermediate language disassembler. Press the enter button. This window will open, right? From this window, select file, open, right? Then you need to check where your application is exe file is generated or where is your assembly is generated. You can see there is something build debug. This is your exe file. You need to copy this path. You need to go to this location. You need to open this location. In this location, you will find that exe. Select that exe and open that exe. This is going to be your intermediate language code. And we need to check the destructor code. So this is, you can see, this is your CTR constructor and this is your finalize, right? So internally, the destructor is implemented as a finalize method, right? Internally, your destructor is implemented as a finalize method, and that method you can see void method and zero parameter. That means you cannot return anything and you cannot pass any parameter. So void and this symbol means it doesn't take any parameter and doesn't return anything. And your constructor is implemented as a finalized method. Now, to see the intermediate language code, what you need to do is you need to double click on this method. I just double click on this and you can see this is the code which I have got, right? You can see this destructor method is implemented as a finalized method. And as part of this finalized method, it has something called a try block and it has something called finalized block, right? Whatever code you have written in your destructor, that will become inside this try block. And from the finally block, it will invoke the superclass finalize method. It will invoke the base class or the superclass finalize method, right? Now if you look at our code, then for this sample class, who is the parent class?
Object.
Object class is the parent class. So you can see it is calling the object class finalize method, right? It is calling the object class finalize method. So this is how your destructor is implemented. Your destructor is implemented as a finalized method having try and catch block. Whatever code you have written inside your destructor will become inside the try block, and from the finally block, it will invoke the finalized method of the superclass, right? Now if you come to this part, this is your IL code, and to understand this thing better, so I have converted this sample class to this finalized method. So you have written this code in your class, but after compilation, this code will be converted to this code. So this is nothing but your how the destructor function is implemented in your application, right? Whatever code, whatever statement you have written inside your destructor for cleaning of the object, right? For object cleanup, those statements will become inside the try block, and we know that, right? Finally block is guaranteed to be executed, right? Suppose you have written some statement inside the try block, some exception occurred or not, right? It doesn't matter. The final block is going to be executed. Once you execute this final block, then it will call the superclass finalize method, right? The superclass finalize method means what? The superclass destructor. Again, the superclass destructor having this format. That destructor again will be converted into this format. Again, that constructor having try and final block. Again, that constructor is going to call its superclass finalize method. In this way, it will call one by one till it reaches the object class, because object is the superclass. And finally block is the one which is guaranteed to be executed, irrespective of exception occurred or not in the try block. Final block is guaranteed to be executed. So this is how the destructor function is implemented in CSharp. Is that clear? Guys, any question from this one?
No, sir.
Fine, let's proceed. Okay, to understand this destructor execution, so Okay. Let's see this example so that you can understand this better. So this is your first class. This is your second class. This first class having one destructor, and this is your second class. The second class is also having one destructor, but it is inherited from the first class. There is a parent-child relationship between first and second class. For the second class, first class is the parent class, right? For the first class, who is the parent class? Object is the parent class, right? For the third class, second is the parent class. Again, we have defined one constructor. So what I'm doing, I'm creating an object of third class. I'm making that object as null, and I'm invoking the gc.collect. So in this case, what will happen? Can anybody tell me what will be the output? Can anybody tell me what will be the output? See, if you want to understand the output, so whatever code you have written inside your constructor, sorry, inside your destructor, that will become inside the try block. Yes or no?
Yes.
After executing the try block, then it is going to execute the finally block, right? That means whatever code you have written inside your destructor will be executed first, then final block will execute, and from the final block, it will call the parent class destructor, right? So in this case, so when the destructor function trying to destroy the object, first of all, it will execute this statement or not, because this statement is going inside the try block. That means this statement is going to execute first. Yes or no?
Yes.
After executing this statement, what it will do from the final block, it will invoke the parent class destructor. That means this destructor then going to execute. Right? Once execute this destructor, again the final block is going to invoke the parent class destructor. Right? That means this destructor is going to execute. After executing this destructor, again it is going to invoke the object class destructor. There is nothing to print, so you will not see any kind of a printing statement. So when you run this application, even you create the object of a third class, and when your third class object memory location is destroyed, so the garbage collector will print the statement or destroy the object from the lower or from the most recent object, right? So it will destroy the child class object, then it will destroy the parent class object, then it will destroy the parent class object. Now if you run the application, then you will see that first this destructor function is called, then this one, and then this one. Okay. Now I'm not able to run the application. The reason is I'm already opening the ILDSM tool, right? If you want to run your application, then first of all you need to close your ILDSM tool, right? Once you close the ILDSM tool, then only you will able to run your application. Now run the application. Right? So you can see destructor of third class, destructor of second class, destructor of first class. This is the way, this is the execution order of destructor function. Is that clear? See, the thing that you need to remember is, right? So what diagram I'm showing here, this is the sample class. I mean, whatever constructor you have written, all these constructor are going to be converted into this format. It is not like that. The third class constructor will be converted like this. Even the second class constructor is going to be converted. Even the first class constructor is going to be converted. And this statement is nothing but calling the superclass constructor, calling the parent class constructor, calling the base class constructor. That means it doesn't, that means when you invoke this, it will automatically invoke the parent class constructor. This constructor will automatically invoke this destructor will automatically invoke the parent class destructor. So from here only it will execute this statement, then this statement, then this statement, right? But this is the execution order of destructor. But what happened? And can you guys tell me why whenever I'm deleting this object, why this is going to be deleted? Why this is going to be deleted? Can anybody tell me? Can anybody tell
Internally,
me?
it will call finalize method. In that, we'll be having that parent class destructor is being called.
Yeah, that is absolutely fine. Internally, it is calling. But my question is, why it is calling internally to the parent class destructor? If you want to understand why it is calling the parent class constructor, then you need to understand the destructor. Then you need to understand the constructor, right? So Constructor. So this is your public constructor. This is your parent class constructor. This is your parent second constructor, right? Second, right? This is your right. This is your third. Okay, right. So in this case, I'm creating a constructor in first class. I'm creating a constructor in second class. I'm creating a constructor in third class, right? So whenever I'm creating the object, this object, how the constructor are going to be executed, right? So we are creating the third class object, right? That means this constructor should be executed. But before executing this constructor, it will call its parent class constructor. And again, before executing this constructor, it will call its parent class constructor. Why? Why? Because we are making the inheritance relationship. Inheritance relationship means whatever data member and properties and methods available in your parent class, all are inherited to the child class, and by using the child class object you can access the parent class member. That means whenever you are creating an instance of a child class, using this child class instance you can access the parent class members or not. How you can access? Because when you are creating the child class instance, along with the child class member get memory allocation, the parent class member also get memory allocation, right? So whenever you are creating third class object means whatever member you have declared inside this class, whatever member you declared inside the second class, and whatever member you declared inside this first class, all are getting memory allocation or not? For example, I'm declaring one variable here, public integer x equals to 10. I'm storing this variable, right? I'm storing this variable y here, right? I'm storing this variable z here, right? I'm storing this variable z here, right? Then by using this object, I can invoke the console.writeLine, right? What I'm doing, obj.z, even you can access obj.x and obj.y, x, y, right? Okay, let me comment these two statements, right? Now let's run the application. See, you can see 10, 10, 10. Why? This 10, 10. All are getting memory allocation or all initialized. How? Because whenever you create an instance of the parent class constructor internally, whenever you are creating an instance of a child class, the child class constructor internally call the public accessible constructor of the parent class, right? Yesterday we have only discussed, na? If you want to make a parent-child relationship, then the parent class constructor should be accessible to the child class. Why? That the reason is while creating the instance of the child class constructor internally call the parent class constructor. Why it internally call? That to initialize the parent class member, to get memory allocation for the parent class member. Until and unless this constructor is not invoked, so this variable will not get memory allocation. This variable will not initialize until and unless this constructor is called. This memory location, the memory location for this variable will not be there. This variable will not be assigned with value 10. That means, but here we are getting the value of 10 or not. We are able to access this x and y and z. Why? Because these x, y, and z are getting memory allocation. How they are getting a memory allocation? Now, whenever we are calling the child class instance, the child class constructor is called. Now, before executing the body of this child class constructor, this child class constructor will call its parent class constructor. So in this case, which is its parent class? This one is the parent class constructor. Right? This parent class constructor, before executing the body, it will call its parent class constructor. So who is the parent class of this class? Now this class is the parent class. So this constructor will internally invoke this constructor. And when this constructor execute, the memory allocation for this x variable will be there, and it will assign that value 10 to that memory allocation, right? Once this constructor execution completed, the controller will come back to this place only. And once it come back to this place, it will execute this body. After executing this body, this memory, the memory location for this variable is going to be allocated. right? The variable, the memory location will be assigned with this value, right? After executing the body, again the controller will come back to this place now, because from here only we are calling this constructor, right? Now what will happen now? It will execute this statement and it will allocate memory for this variable, and it will initialize that memory location with this value. So this is the reason why we are able to call this. So the point that you need to remember is, whenever you are creating an instance of the child class, internally the child class constructor calling the parent class constructor. As we are as whenever creating the object, we are calling the parent class constructor. So same way, whenever we are destroying the object, the parent class memory location should be destroyed or not. And this is the reason why the destructor internally call the parent class a destructor. But the difference is that constructor execution always takes place from the parent class, but the destructor execution always takes place from the child class. So if you run the application, you will see that constructor execution order and destructor execution order. You can see constructor of a first class, constructor of second class, constructor of third class. So this is the execution order from parent to child. But for destructor, first child class, then immediate parent class, then the immediate parent class. This is the order of a destructor, and this is the order of constructor. Is that clear why this destructor function called its parent class destructor? Is there any question?
No, sir. Clear.
Okay. No, it is clear.
Okay, fine. Right. Now, you might have one question in your mind. Sir, the memory management is automatically done by the garbage collector. Then why do we need to use constructor? Right? So you might be this question on your mind now. The memory allocation and deallocation is automatically done by the garbage collector. Then why, as a developer, I'm going to write the destructor in my application, right? So the point that you need to remember, as a .NET developer, we need not to think much more about the memory management. This is the .NET framework. This is because the .NET framework handle internally, right? Inside the .NET framework, there is a component called CLR. As part of CLR, there is a component called garbage collector, and that garbage collector internally manages the memory allocation and the deallocation for your application. That means whenever we are creating an instance, how the memory is going to be allocated, right? How the memory is going to be allocated inside the RAM, that will be taken care by the garbage collector. And garbage collector know this is the object, and this object is created inside this memory location. Then when the memory is unused, garbage collector know na where he allocates the memory, so it will go to that place and it will destroy that object, right? So the memory allocation as well as deallocation is completely managed by the .NET framework. And inside .NET framework, there is a component called CLR, and as part of CLR, there is a component called garbage collector who is going to take the responsibility for managing and for allocating and for deallocating the memories, right? However, when our application work with the unmanaged resources, right? So, but the thing that you need to remember, garbage collector will only allocate and deallocate memory for managed resources. If it is unmanaged resource, then garbage collector is not going to handle this thing, right? Suppose you are working with the Windows files, you are working with the network connection, then these are going to be unmanaged code, right? So unmanaged code means the memory allocation and the deallocation is not controlled by the garbage collector, right? So if you are allocating memory, then as a developer, you should deallocate the memory. If you are not deallocating the memory, then you will get the memory leakage issue, right? So whenever you are working with the unmanaged code or unmanaged resources, then as a developer, we need to write a destructor, and as part of the destructor, we need to write the code to clean up the unmanaged resources, right? Is that clear? Is that clear? Okay, to make you understand what I'm going to do, I'm giving you one simple example, right? So that you will get some idea. Okay, think that this is an unmanaged resource, right? So whenever I'm saying resource means it's a class, nothing else, right? Suppose this is an unmanaged resource, right? And this unmanaged resource is not automatically collected by garbage collector, right? So garbage collector is only going to destroy the object, but it will not automatically destroy the unmanaged object. If it is a managed object, then garbage collector is going to destroy the resource, right? But if it is an unmanaged object, then automatically memory destroy is not going to be done by the garbage collector. What garbage collector does, if your object is a managed object, then he is going to automatically destroy the object. But if your object is an unmanaged object, then you need to tell the destructor, hey, destructor, it's an unmanaged resource, please delete the object, right? Please destroy the memory location, right? Then in that case, you need to use the destructor, right? Suppose this is your unmanaged resource. So this is the constructor and this is the destructor, right? Unmanaged resource means you need to write the destructor function, and as part of the destructor function, you need to write the cleanup code, right? And then you need to tell the garbage collector, hey, garbage collector, this is my unused resource, please destroy this, destroy the object, right? Then the garbage collector is only going to destroy the object, right? Now, now if you run the application, you will see the object. So unmanaged resource is created, right? Using the unmanaged resource, and the unmanaged resource is destroyed. See, in your application, whenever you are working with the unmanaged resources, then you need to write the destructor, right? And once you write the destructor, then the garbage collector, before deleting or the so the garbage collector periodically will visit, and before deleting the object, right? So it will check whether this class having any destructor or not. If the destructor is there, then it will execute that destructor and will delete the object, right? But the thing, the point that you need to remember is, if it is an unmanaged resource, writing destructor is fine, because automatically memory is not going to be deleted by the garbage collector. But if it is an unmanaged resource, then you need to write this destructor, right? Once you write a destructor, the memory is going to be deleted by the garbage collector, right? But if it is a managed resource, not required, because automatically memory management is done by the garbage collector. So the point that you need to remember is, if you are having the managed code, if you are creating some managed resources in your application, the garbage collector will automatically delete those objects and free the memories which is allocated for those objects, right? But if you are working with unmanaged resource, then automatic memory deallocation is not there. Memory automatically, garbage collector will not deallocate the memory for unmanaged resources. For that, you need to write destructor. But while you are writing destructor, you need to make sure your class having only managed resource or unmanaged resource. Managed resource means automatically done. But if you are writing destructor, automatically garbage collector will not going to destroy, because your class having destructor. Before destroying the unused object, first it will ask the class, hey, Mr. Class, do you have any destructor? Yes. Then don't delete the object. Let the destructor to do the things, right? So this is the point that you need to remember. Is that clear?
Yes.
Sir, how we will identify this resource is managed or unmanaged?
Hey, see, the managed and unmanaged means while you are working with the DLL, then you need to check whether that DLL is managed by a .NET framework or any third-party companies, right? So whenever you are working, so some of the DLL are provided by Microsoft, which is a part of our base class libraries, right? And some of the DLL which you are going to use is not managed by .NET framework. Those are third. Suppose you are working with MS Office. Then for MS Office, separate DLL is there, which is not managed by .NET framework. So those are unused object. And not only you are going to use this destructor function to unuse the unmanaged object, but if your resource is a heavy resource, right? Suppose you are working with a heavy resource, which is taking more memory in the computer, right? So waiting for garbage collector to destroy the memory, so you can make a request to the garbage collector by putting a destructor in your application. You can request a garbage collector so that the garbage collector will destroy the memory immediately, right? So the two things you need to understand. One is unmanaged resource and another one is heavy resource. Heavy resource means that resource is going to take more memory inside the RAM. And if that object taking more memory, then instead of waiting for the garbage collector to destroy that automatically, we can delete them whenever it is not no more used, right? In that case, you can also use Destructor, but using Destructor is a it will degrade your application performance, right? Then how we can destroy the heavy resources, that we will also see, right? That how we can implement the code in a better manner so that we will not degrade the application performance, but it will delete the unused memory immediately so that we will get better performance. That we will also see, right? Right. See, in this example, suppose you are working. So in this example, whenever you are using Destructor, then it is going to degrade the application performance, right? How it is going to degrade the application performance, that we will see tomorrow, right? But for now, if you want to restrict this, right? If you don't want to degrade your performance, then what you can use is dispose pattern, right? There is an interface called iDisposable, and you need to implement that iDisposable interface on your class. That iDisposable interface provides a mechanism to clear the managed and unmanaged resources, right? How we can implement? Let's see, right? If your application using an expensive external resource, a heavy resource, then it is recommended to provide an explicitly way to release the resource before the garbage collector frees the object, right? So if your application using some external resources, which is a heavy resource, then you don't wait for the garbage collector to release the object, right? You can provide an explicit way to release the object. To release the resource, it is recommended to implement dispose method of the iDisposable interface, right? That iDisposable interface will provide some mechanism, some pattern. Using those mechanism, using those pattern, we can release the expensive resources from our application, right? Suppose this is your unmanaged resource. So what you need to do, you need to implement this iDisposable interface. And there you can see implement interface, and there is another option, implement interface with dispose pattern, right? People are having many confusion. What is this iDisposable interface? Some of the code while I am working, I am seeing that the class is implementing the iDisposable pattern. Some of the already created classes provided by the .NET framework I'm using. Then again, I have seen some of the time they are making a call to the dispose method. Sir, I don't know what is this dispose method. I don't know what is this dispose pattern, right? People who are working with the real-time application, they might be using this iDisposable pattern. They might not be used. What is the use? How this disposable pattern is implemented, right? Let's have a look and let's understand what exactly this, right? Suppose this is your class. And in this class, I'm having both managed resources and unmanaged resources, and both are having a heavy resource. Heavy resource means they are going to take more time. And if that is your case, then how you can freeze the memory without waiting for the garbage collector to destroy them automatically? How you can explicitly do the same thing? So what you can do is you need to implement iDisposable pattern, right? So iDisposable pattern means you will see that there are implement interface with dispose pattern. Once you click on this, it will give you the basic structure, right? Give you the basic structure how you can implement this iDisposable pattern. So you can see there are a few things to understand. They have created one private variable, disposed values, right? Disposed values mean to detect redundant calls, right? Suppose we are providing an explicitly mechanism to destroy the object. If we are providing an explicitly mechanism, then we need to make sure that the object, what code we are written, is going to be executed only once. It should not be a redundant call. Redundant call means one request we make, it destroys the object. Again, one request we make, then it should not execute the code. It should check whether the call is a redundant call or not, because I'm not going to destroy the object 2 times now. And here we are providing an explicitly mechanism, right? Explicitly mechanism means we need to handle the things by ourselves. We need to handle by writing the code, right? So to handle the explicitly or to handle the redundant call, to handle the duplicate code call, this variable is there, right? How we'll use this variable? Let's see. So there is a method called the dispose method, right? As part of the dispose method, it will check first of all, it is initialized with the value false, right? Then not false means if the value false means this statement is going to return true, right? And once it return true, then it will execute this block of code, right? Once it is true, it will execute this block of code, and after executing, it is making this variable as true, right? Second, again, if I am calling this method for the second time, then it will check what is the value. The value is true. True means it is not operator is there, so it will return false. So it will not destroy the object, right? So this is the use of this variable. This variable will identify whether I need to execute this piece of code or not. If it is not executed, then it execute it, and once it is executed, don't execute it. And this is the reason why we are using this variable. Now, second, you can see this dispose method taking one Boolean value, right? And this Boolean value will identify whether I need to write the code to clear the managed object or not, right? If your class having some managed resources, and if you want to clear the managed resources as part of this method, then you need to write the code here, right? Manage the resource release code you have to write here. But whether I need to execute this code or not, that basically depend on this variable, right? Suppose from external application we are making a request, we are calling this dispose method, right? And while calling this dispose method, I just want to delete the unmanaged resources. I don't want to delete the managed resources as part of this dispose method, and even I'm not creating any managed resource as part of this object, right? Then you need to pass this value as false, and once you have passed this value as false, then this statement is not going to be executed. Means whatever statement you have written inside this block is not going to be executed. But it doesn't matter if you write managed object logic here to if you write managed resources cleanup statement here, then also those statements are not going to be executed, right? If you want to execute, then you need to pass the value as true, right? And whether you release the managed resources or not, but unmanaged resources are going to be deleted for sure, right? You have to write the code here to manage to release the unmanaged resources, right? After performing the activity, you need to set this value to true. Once you set this value to true, second time if you are calling this dispose method on this object, then this method is this piece of statement is not going to be executed. Is that clear? Any question from this method, guys?
So using dispose, we can dispose even managed codes and unmanaged codes as well.
So this is the pattern which is provided by the framework, right? You can see already they are given to means to do. Dispose to managed state, right? If you want to dispose to managed state, then you need to write the code here, right? And then you will decide whether I need to dispose the object or not. That I will show you. Both the things I'm going to show you. But from now, you just need to understand here, you need to write the code. Give me 1 minute. Right. So the point that you need to remember is this is the pattern. Pattern means you need to write the managed code resource cleanup statement here, unmanaged code resource cleanup statement here, right? How you are going to use this method? By passing the true and false value. If you want to clean both managed and unmanaged code, then you need to pass the value true while calling this dispose method. And if you only need to clean up the unmanaged resources, then you need to call this method by passing the value false, right? So, but as part of this method, we have both the mechanism to clear the managed resources, mechanism to clear the unmanaged resources. How you are going to call this method, that basically decide whether you need to clean up both managed and unmanaged resources, or you only need to clean the unmanaged resources. Is that clear?
Yes.
Okay. See, once you do the practical, once you execute this code, then you will get some better clarity, right? Then you can see to override a finalizer only if dispose this above code as okay. See, so this is nothing but you can see this is nothing but your constructor, right? So this constructor is commented by default, but thing is that suppose you have implemented this method, and as part of this method you have only written code to manage the you have written only code to clear the unmanaged resources. That means managed resource cleanup statement you have not written here. You have not written any code to clear the managed resources. Then you can write the same thing inside a constructor, right? So inside a constructor, you can write the code here to clear the managed resources. And after after clearing the managed resources, you can call this dispose method by passing the parameter false. So in this case, what will happen? See, now you are calling this method by passing the parameter false. You have written the constructor, and as part of the constructor, you have written the managed resource cleanup statement. You have cleared the managed code. But again, if you want to clear the unmanaged code, then you need to call this method by passing the parameter value false. Once you pass false, then this statement is going to execute it or not? Guys?
No.
That means the managed resource statement, the managed resource cleanup statement is not going to be executed, right? Because we have already executed those statements as part of your constructor. Sorry, as part of your destructor. Is that clear?
Yes.
Yeah. So here he is saying now override a finalizer only if bool disposing above has the code to free unmanaged resources. See, this method, if this method is only used to free the unmanaged resources, then you need to override the finalizer. Finalizer means you need to override the destructor. But if this class having both, if this method having both code for clean up the managed resources and unmanaged resources, then this method or this constructor is not required. Is that clear? This destructor is no more used because we have this dispose method, and that dispose method have the logic to free up the both managed and unmanaged resources. But as part of this method, if you do not write any code, suppose this block is not there at all, right? Then you need to write this constructor, right? And then another dispose method. And in this dispose method, do not change this method. Put cleanup code in a disposal bool I disposing above, right? And you just need to call this dispose method by passing the true method, right? So when you call this dispose method by passing true means what? Now you are passing this method with a true value. This is coming as a true. True means it will clean the managed resources or not?
Yes.
And again, you have to write code here to clean the unmanaged resources. That means this method is going to clean both the both managed and the unmanaged resources. Then he is saying, uncomment the following line if the finalizer is overridden, right? Suppose you have written a destructor on your application, right? Suppose you have written a destructor on your application, then only you need to uncomment this statement. So what this uncomment statement means, gc.surface finalize. So gc.surface finalize means it will tell the garbage collector, hey, Mr. Garbage Collector, please ignore the destructor of our class, right? Whenever you are invoking this dispose method, then it will tell the garbage collector, hey, Mr. Garbage Collector, just ignore this destructor. Just ignore the destructor of this class, so that the destructor function is not going to be checked again, and it is not going to be executed again, because you have already written the code here. You have already calling this dispose method, and that dispose method already cleaning up the managed and the unmanaged resources. Then again, no need to use the destructor.
right? Don't use the destructor. Destructor is there in the class, but don't use that one. So just ignore the destructor, right? And you only need to uncomment this statement only if you have written a destructor for your class. But if you have not written any destructor, then no need to uncomment this now, because destructor function is not there. Then why should I uncomment this, right? So this is how you can implement the dispose pattern, right? Now let us see the example so that you will get a better understanding how it is actually working. Right? Right? Suppose this is the same code, right? So what I'm writing now, I'm writing the code managed resources destroyed by dispose method. This is dispose method, and I'm writing a statement here. Manage the resources destroyed by dispose method, and I'm writing another statement here. Unmanaged resources destroyed by dispose statement here. So this dispose method this dispose method what I have created is going to destroy both managed and unmanaged resources. And here you can see I'm using that disposed value, right? If the resource is already deleted, if the object is already destroyed by the garbage collector, then if you are invoking, then you are giving one message: resources are already destroyed by the dispose method, right? First time it will destroy the resources. Second time it will not destroy the resources, rather it will give one in message that already you have destroyed the resources, so we cannot destroy them again, right? And this is your constructor. So what message we are printing here? Request comes to destructor to destroy the resources, right? And here you can write right, so here you can write code here to destroy the managed resources. Managed resources are destroyed by destructor. Right. So you can see like this. The request comes to destructor to destroy the resources. Managed resources are destroyed by the destructor method, and after destroying the managed resources, it is calling the dispose method by passing the value false. And you can see if this is false, then this managed resource statement, deleted statement or resource cleanup statement are not going to be executed. It is going to execute this statement only. That means unmanaged resources, right? And then you can see this is our dispose method, and this method we are going to call from our application. When the request comes to this method will call this dispose true. That means it is going to execute both managed and unmanaged resources. Then as our class having the destructor, we are calling this gc.surface finalize method, so that the destructor function is not going to execute any more, right? Then from our class we are creating one resource, right? And we are initializing that resource, and we are giving one message that using resource, right? And then we are checking if resource is not equals to null, right? If this object is not null, then dispose the object, right? In this case, it will call this method. In this case, it will execute this statement. After executing this statement, it will call the dispose method by passing the value true. And once it passing the value true, this statement is going to be true. So this statement is going to be executed. After cleaning of the managed resources, then the unmanaged resources cleanup statement will be executed, right? And further, again, I'm trying to call the dispose method. Now I'm again trying to call the dispose method. Already the resource, already the memory allocation, what is done for this object already cleaned. Then again I'm trying to call the dispose method. But when I'm trying to call the dispose method again, then it will check. You will see that this message is printed. Request comes to dispose method, but once it will come to this place, then it will check this value is true. This value is true. True means this statement is not going to be executed. It will print this message, right? Now let's run the application and see the output. See, you can see using resources, then we are calling the dispose method to destroy the resource, right? So you can see first two statements. So using resources, then calling dispose method to destroy the resource, right? After calling the controller, then the controller will come to this method, right? So you can see Request comes to dispose method to destroy. Request comes to dispose method to destroy the resources, right? Then it is calling the dispose method. Dispose method true means it is calling to this method. So here we are passing true. First time this value is false. False means this condition will be satisfied. Satisfied means it will come inside. Again, we are passing true means this statement is going to be executed. Manage the resources. You can see manage the resources, destroy by dispose method. Then unmanaged resources, destroy by dispose method. So you have already destroyed the managed and unmanaged resources, right? Now again you are trying to call the dispose method again, trying to call the dispose method again to destroy the resource, right? Already you have called. So once you call this method dispose method, the controller will come to this place, right? Again you can see request comes to dispose method, and now the dispose method calling this overloaded version of the dispose method, which is taking one boolean type parameter. So the controller will come to this place, but in this place you can see this disposed value is already true. True means this statement is going to be skipped and this statement is going to be printed. Resources already destroyed by the dispose method, right? Now to understand this, now what we'll do, we are going to debug this application to get more clarity whether this destructor is executed or not. We will see everything in practical, right? Right. We run the application. The program execution always, as usual, going to start from the main method, right? I'm pressing F10. So F10 now. So you can see the resource is null, right? But once this statement is executed, this object is going to be created and that reference will be stored inside this reference variable, right? Now you can see the resource should not be null. It should be destructor demo.unmanaged resource, right? So now we are using the resource, right? We have completed our using resources we used. Now we don't want the garbage collector to destroy the object when he has some time. Rather than we are explicitly destroying the object. How we can explicitly destroying the object? By using the dispose method, right? How? Let's see. So here we are checking the resources is null or not. Or no, the resources is not destroyed yet. We need to destroy this. So you can see this statement is not null and this is going to be true. So it will come inside the if block. Now we are calling the dispose method to destroy the resources. So now you will see that the controller will come to this dispose method, right? But before that, we just need to make sure, see, disposed value is false, right? So now this statement is printed and now we are calling the dispose true. Dispose true means you will see that this value is coming as a true. And you will see that this is false value because we have not changed the value yet, right? Again, what I'm doing, I'm checking whether this value is false and not false means it will return true. True means it will come inside. And what we are passing true. True means we are also going to destroy the managed resources. Managed resources destroyed, unmanaged resources destroyed, and we are making that disposed value to true. Now you will see that this value is true, right? After this statement is executed, then we are telling the garbage collector, we have delete all the managed and unmanaged resources. Don't try to execute the destructor, right? So just ignore the destructor. That is no more use. So we are just coming outside and outside and outside. Again, we are trying to call the dispose method. Now we are calling the dispose method. Again, the request come. Again, we are calling the dispose method by passing the value true, right? But this time you will see that the value is true. Already we have destroyed. So it will return false. So false means you will see that this block will not going to be executed. Rather than this statement is going to be executed. See, this statement is executed. So in this case, we can implement our dispose pattern, which will improve our application performance. Now you will see that the destructor is not going to be executed. Why destructor we are not executing? Why destructor function bad performance? Tomorrow we will discuss. But if you still want to use the destructor to destroy the object, you can also do the same thing. Let's see how, right? Suppose you have created one resource, right? Suppose you have created one resource and you are using that resource, right? So you have created one resource and using that resource, right? After using that resource, so what you are doing, you are making this method as a resource equals to null so that it is eligible for garbage collector, and then you can make a collect call to the gc.collect method, right? So in this case also the destructor function is going to execute, and you will see that how it is going to work, right? So the program execution started, right? Now we are not using the dispose path. What we are using? We are using the okay, function 10. So now we are making the gc.collect. We are making a request to the garbage collector. See, we should not write this statement here, right? See, the request comes to the destructor. Now the request comes to the destructor. Now this method is called by the destructor, right? And you can see manage the resources deleted, then it is calling the dispose method. And in this case, you will see that it is not going to false. False means it is going to skip this statement execution because already managed resources are deleted by the destructor. This is how your application will work. So in this case, you are having both options. Both options means if you want, you can use destructor to destroy the object. Even if you want, you can use dispose pattern, right? So if you fail to call the dispose method, then this destructor will work as a backup, right? If you fail to call this dispose method, then destructor anyhow is going to invoke now, because we are not telling this garbage collector to ignore this method. Whenever this statement is executed, this statement will tell the garbage collector to ignore the method, right? Ignore the destructor. But if this method is not execute at all, that means we are not telling the garbage collector to ignore this method. That means the destructor is going to be invoked by the garbage collector, and that destructor will destroy the managed object, and it will call this dispose method internally to destroy the unmanaged resources. So this destructor function will act as a backup